Okay, this is a question from a middle school student in Hampton.
What exactly is global warming? What does it do? And how can we find that out?
Okay, did you guys get that? What is global warming and what does it do and how do we find out? Okay.
Okay, well, I'll take a stab at that. Global warming is the process, I guess, the name we've given to what we're doing to the atmosphere right now and doing to our planet as a result of increasing the amount of carbon dioxide in the atmosphere due primarily to the burning of fossil fuels. What you have to step back, and I don't have a figure to show here, but basically you can think of our climate as being regulated by a balance of energy coming in from the sun that warms the planet, and if it didn't have a counter mechanism, the planet would heat up and we'd all melt. But we do have a counter mechanism to that. It's called infrared radiation. Everything that in the universe emits infrared radiation. Everyone in this room is emitting infrared radiation based on your temperature by well-known physical principles. So the Earth itself radiates infrared energy back to space, and it's the balance between the incoming radiation to Earth from the sun and the infrared radiation going back to space that keeps the Earth's temperature where it is and in the zone that we can all live in. And part of the reason that well, actually not part of it, the main reason that the Earth is warm enough for us to live on is that we have this very thin atmosphere that has been talked about around the planet, and that's composed of a number of gases, nitrogen and oxygen being the most, but then there's a number of minor gases like carbon dioxide, methane, ozone, and others that are very, very active in the infrared. That means that they absorb infrared radiation very, very intensely. And those are spread throughout the atmosphere. And so as the Earth is trying to emit this infrared radiation back to space, the gases like carbon dioxide in the atmosphere absorb some of that, and it gets radiated back to the surface. So it's an additional source of energy down here at the surface in addition to the solar energy that warms the planet. So that's a very basic overview of how the greenhouse effect works. It's there. It's been there since the beginning. What we're doing now is we're changing the greenhouse effect by putting in more of these infrared absorbers, carbon dioxide, methane. We're increasing their amounts, and so we're increasing the amount of energy coming back down to the surface, out of the atmosphere. And when you increase energy without another mechanism to balance it, things have to warm up. And so that's what global warming is. It's the increase in temperature of the planet due to our putting more of the carbon dioxide, these infrared active gases, as we call it, into the atmosphere and increasing the amount of energy at the surface and warming it. And it's been, well, it's been going on since really the start of the industrial age back in the 1750s when large amounts of fossil fuels were consumed. But then as society has continued to evolve and modernize and being able to consume more and more of these gases, we're putting more and more into the atmosphere at a ever-increasing rate. If you look back over the last 100 years, the amount of CO2 going in the atmosphere has increased tremendously. And so that's the source of global warming. It's just increasing the natural process by which it keeps the Earth at its given temperature, but we're adding to that, we're increasing the temperature with possible consequences for society.
Plants and photosynthetic bacteria play a major role in this because they pull carbon out of the atmosphere and sequester it in their tissues, and in fact are making fossil fuels now that if anyone's around in a few 100,000 years, they could probably harvest then. That's the problem, though, is that the carbon from the last several million years of photosynthesis is all sequestered and stuffed away down in the bowels of the Earth. We're hauling it out and putting it out into the atmosphere. And the rate at which we're doing that is faster than the rate at which the biological processes which pull that carbon out of the atmosphere can do that.
Okay. Audience?
Can I ask the audience one thing? Do people here actually know how molecules warm the atmosphere by global warming? Do you know? Because a fundamental thing is understanding how it actually happens. Is there anyone that doesn't know and wants to know on a molecular level? Yeah, it's actually very simple. Marty had it right that we talk about CO2, but there are actually a variety of different gases. But how these gases actually work in the atmosphere is the infrared light, which is energy that's radiated from the Earth, is converted into kinetic or thermal energy by these molecules. These molecules are a variety of different shapes, but say water molecule, it's not something that's talked about as a greenhouse gas, but a water molecule is a V, looks like this. It's an O in the middle, an oxygen, and two hydrogens on either side. When some infrared radiation hits that, it causes that molecule to wobble. It bends, it stretches, it twists, and all of that creates heat. So that's actually the fundamental reason why greenhouse gases warm the atmosphere. It's translating that infrared light energy into heat in the atmosphere. And not every gas in the atmosphere does that, just certain gases. So I just wanted to add that for those of you that didn't know at a fundamental level how it works.
If I could just add a point to Bruce's there too. He mentioned water vapor, and you don't hear a lot about water vapor in terms of greenhouse gases, but water vapor actually is the main greenhouse gas in that it is responsible for over half of what we call the natural greenhouse effect, for this warming of the atmosphere that we talk about. But the fact is we're not changing directly, I should say, we're not directly changing the amount of water in the atmosphere. We are changing the amount of CO2, which is then driving this whole CO2 and methane and other greenhouse gases, but water vapor is the main greenhouse gas. It's like the greatest experience, we've all experienced this here, on a cold night in the wintertime, what type of night gets colder? I'll ask it in form of a question. You've got an overcast night or you've got a clear and dry night. Which night gets coldest? Answer? Clear and dry night. That's because there's much less water vapor in the atmosphere, and there's not an infrared shield like a cloud underneath it, so the Earth can radiate much more effectively and cool down, radiative cooling at night. So that there, in a nutshell, is the greenhouse effect. When you have a cold, dry night, you have less of the natural greenhouse effect of water vapor, and it gets cooler, but then you have clouds or you have a lot of moisture, like summertime at Hampton Roads. It doesn't cool off at night because we've got very high humidity outside. Again, that's the natural greenhouse effect that's going on right there. And what you have to understand then is that what we're changing is the carbon and the other CO2 and the other gases in the atmosphere that also contribute to the greenhouse effect, and that's what's causing the planet to warm. But a number of gases really contribute to the natural greenhouse effect.
How much would you say that global warming is our fault and how much it's just natural?
What do the tree rings say?
So part of it is our fault, actually, and you want to think of it because there's an old say, or if you read other people's work, they will say, if it wasn't for the increase in the carbon dioxide that we have emitted into the atmosphere, whether 8,000 years ago or only 150 years ago, we would have started going into a glacial period, or we should have started going into the cooling period, which started almost at 1480, and we started having a little bit of cooling, then we snapped out of it, and we started getting more into the warming. So part of the global climate change is to be blamed on us by having all of this CO2 emissions into the atmosphere and increasing the temperature. This comes in, again, as Bruce said, it's come in clearly in the tree ring record and the pollen record that we are having a change in the response of, if I say the word biosphere, I guess everybody will know that's that biotic effect of the whole Earth, have been changing in their response. Instead of changing completely or responding completely to temperature, they're responding to something else. And we're finding more and more evidence that especially plants, for example, and tree rings, are responding to the carbon dioxide into the atmosphere. So yes, part of the global warming is to be blamed on the human beings doing this activity. But again, remember, everything in science is a hypothesis and need to be proven. And we're finding more and more evidence to it.
But the more and more people that ask that question, the better off we're going to be. The people are thinking about that. That's good.